In the figure below, AB is 11 centimeter, BC is 8 centimeter, AD is 3 centimeter, AC is 5 centimeter, and angle DAC is a right angle. Calculate correct one decimal place the length of DC, the size of angle ADC, the size of angle ACB. So now we want to calculate the length of DC. The length of DC here. DC is opposite A here, so we can name it as A. So we want to apply Pythagoras theorem to find the length of DC, which we can name as A here. So the length of DC, you can say that DC, which we can name it as A centimeter, by using Pythagoras theorem, we can say that A squared is equal to 5 squared plus 3 squared. A squared is equal to 5 squared plus 3 squared, using Pythagoras theorem, and that is giving us a 25 plus 9, which is equal to 34. A squared is equal to 34. Therefore, A is equal to square root over 34, which is giving us 5.8 centimeter. So here our A is 5.8 centimeter. So the length of DC is equal to 5.8 centimeters. The size of angle ADC. The size of angle ADC, this angle here, the size of angle ADC, we can name it as angle D. We can name it as angle D. So you can say this is angle D degrees. Angle ADC, we can name it as D degrees. So we apply the sine rule. We apply the sine rule in order for us to get angle ADC, and the sine rule is that this is a 5.8. The sine rule is that this is the opposite angle here. We say that 5.8 over the opposite angle is equal to 5 over the opposite angle, which is D here. So we can say that 5.8 over the sine over 90 degrees This angle is 90 degrees. It is a right angle, so it is 90 degrees is equal to 5 over sine of d degrees. So we are applying the sine rule, and this will give us we cross multiply. You can say that 5.8 times sine d degrees is equal to 5 times sine 90 degrees. We have cross multiplied. So here we can say that sine d degrees is equal to 5 times sine 90 degrees over 5.8. So now this is going to give us sine d degrees is equal to 5 times sine 90 degrees is 1 over 5.8, which is equal to 0.8621, and this is giving us 59 degrees. 59 degrees. So we can say that angle ADC is 59 degrees. 59 degrees. Angle ADC is 59 degrees, applying the sine rule. So now we go to part C, the size of angle ACB. The size of angle ACB, which we can name as that is the size of angle ACB. We can name it as angle C. Angle C. You can say this is C degrees. So how can we find the size of angle ACB? We apply the cosine rule, and the cosine rule we apply it. So you can say that C squared, the size of C squared, this size here, C squared, this size, C squared is equal to A squared plus B squared minus 2AB cos C degrees. We want to find C degrees. So our C square, C is here. This is opposite this angle, 11 centimeters. Our B is 8 centimeters. Our A is 8 centimeters. Our A is 8 centimeters. Our B is 5 centimeters. So now we can say that 11 squared is equal to 8 squared plus 5 squared minus 2 times 8 times 5 cos C degrees. 11 squared is 121 is equal to 8 squared is 64 plus 5 squared is 25 minus 2 times 8 times 5. 2 times 8 times 5 is giving us a 8 cosine c degrees 121 is equal to 64 plus 25 is giving us 89 minus 8 cosine c degrees. So now we can bring negative 8 cosine c degrees this other side. It becomes positive 8 cosine c degrees is equal to 89. We can bring 121 this other side. It becomes negative 121. Then now we can divide by, no, we can subtract. 89 minus 121 is giving us negative 32. So 8 cosine c degrees is negative 32. Negative 32. And this is giving us, can say that cosine c degrees is equal to, we divide by 8 both sides, negative 32 over 8, which is giving us a negative 0.4. Negative 0.4. And negative 0.4 is giving us negative 66.4 degrees. Negative 66.4 degrees. And we know that negative 66.4 degrees, we can find it by saying that this is a 180 degrees minus 66.4 degrees. That is giving us 113.6 degrees. So our cosine c degrees will be 113.6 degrees. 113.6 degrees. So our angle ACB is 113.6 degrees. Thank you for watching.